Log on, tune in, find out. Another good idea from Cambridge.
Well, it's a great pleasure to introduce John Polkinghorne to give our next talk. He's a well-known speaker at Parallel. We're very grateful to him for giving us so much of his time and his immense depth of knowledge. And I know you'll enjoy his talk. I'm not going to say a lot about his career because then you'd just hear me all morning and not John, because it's so extensive. But suffice to say that he worked in quantum mechanics, or well, elementary particle physics, for 25 years, mainly at the Cavendish here. Sorry. The Department of Applied Maths and Theoretical Physics here. Sorry, that was an unforgivable sin almost in the Cambridge context. But then in 1979 he resigned that chair and became ordained as an Anglican priest. He served in a couple of parishes, then came back to Cambridge, was president of Queen's College, and as most of you will know, has written many very helpful books on science and religion. We have 3 of them on sale here at reduced price, so do look at those afterwards. But the other thing I was going to commend to you really is that just very recently he's published an autobiography, From Physicist to Priest it's called, which also is on sale here. And I can really recommend this to you. It's quite short, a very enjoyable read, very, let me say it's a very humble piece of writing compared to many autobiographies which are 5 times fatter and full of self-justification. This one isn't. And I found it extremely encouraging, actually, just to read about somebody else's story as a scientist and as a believer, which many of us here are as well. And as I say, I found it immensely encouraging and a very good read and a very good present. So buy one, read it, and then give it as a present to somebody. Or actually, maybe buy 2 and keep one for yourself. So without further ado, I want to introduce John, who's going to talk about critical realism in science and religion now. So over to you, John.
Well, thanks very much, Bob. Well, people sometimes say that science is concerned with fact and religion is concerned with opinion. And people who say that are usually actually trying to devalue religion a little bit. They see science as the source of truth, perhaps the only source of truth. Some people go as far as to say that. Something you can really rely upon, and there it is, and there is no question about it. Religion is opinion, well, you might be tolerantly respectful of that, seen as a sort of cultural activity. After all, it has produced a lot of art and music and things of that nature. But you wouldn't want to take it seriously as giving you knowledge of the way things actually are. At the other end of that spectrum are people who see religion as neither better nor worse than astrology, which is extremely unflattering opinion to express. So, science is fact, to be taken absolutely seriously. Religion is opinion, an optional interest for those who happen to be inclined that way. That's the way the story goes. And I think that story makes 2 very big mistakes. It makes a mistake about the nature of science, and it makes a mistake about the nature of religion. The mistake about the nature of science is that science is a much more subtle and interesting, actually, activity than that is suggested. There are no interesting scientific facts, of course, that are not already interpreted facts. No doubt at one sort of level we can agree that I show you some complicated piece of apparatus, I flick the switch, the pointer moves across the scale to 1.7. We can no doubt all agree that the pointer moved across the scale and came to rest at 1.7. But so what? It's only when we understand what the instrument is doing, what it is measuring, what it is concerned with, that will become an interesting fact. And you can't say what the instrument is doing without using some theory to interpret what is going on. Theoretical opinion is necessary to establish what it is that is actually being measured. Similarly, in many experiments, there will be unwanted, spurious background effects which have to be eliminated. As Bob told you, I was a theorist in particle physics. Of course, particle physics, no theorists are allowed to come within 100 yards of a piece of apparatus, let alone put their hands on it. But one would be shown, say, for example, bubble chamber photographs, extremely complex swirls of lines and so on, absolutely making no sense until they're interpreted by an expert who would say, this is a proton coming along here, and so on and so on. There would be stray lines crossing the thing, which might or might not be unwanted background effects, say, from cosmic rays. Again, you needed theoretical opinion, theoretical judgment, if you like, to eliminate the unwanted effects and to concentrate on the things that you were really trying to measure and observe. So that there are no interesting facts in science that are not already interpreted facts. And the activity of science is much more subtle than the naive picture of unquestionable experimental results confronting indubitable theoretical predictions. There is a much more complicated interchange and intertwining between theory and experiment. There is a sort of circular argument. You need theoretical opinion, theoretical insight to interpret experiments. You need experiments to confirm or disconfirm theoretical options, but there is no straightforward, unquestionable interpretation of what's going on. And so science is much more subtle and much more interesting than a mere collection of facts. And the person in the philosophy of science that I found most helpful in thinking about the nature of science has been Michael Polanyi. And I would strongly recommend to you his great book, which is called Personal Knowledge. Polanyi himself was a very distinguished scientist before he took up philosophy. He was a physical chemist, and many people think that if he'd stayed in chemistry all his life, he might well have won a Nobel Prize for chemistry, so I understand. So he knew science absolutely from the inside, and had a long scientific career, and knew what it was like. When he began to reflect on that, he realized that science, though science is concerned with exploring the impersonal world of events, I mean, that is, in some sense, the source of science's great secret weapon, which is experiment. Science looks at reality at a particular level where reality is treated as an it, as an object. And at that level, you have the possibility of repetition. You have the possibility, if you don't believe what I tell you about the experiment, in principle and sometimes in practice, you can go and do it for yourself. You have repeatability, and that's the great secret success, which encourages the very striking degree of intersubjective agreement that we can attain in science. So science is concerned with an impersonal nature of the world, but it is intrinsically itself an activity of persons. That's why Polanyi called his book Personal Knowledge. The reason for that is that it involves all kinds of skills which cannot be reduced to some sort of protocol that you could depute to a computer to do for you, or a sort of checklist where if you tick all the boxes, you know you've made a big discovery. It involves acts of judgment which can only be learned through apprenticeship in a truth-seeking community. For example, I've already spoken about the necessity in experiments to eliminate background effects, spurious, unwanted effects. There's no little black book that tells you how to do that. It's a skill that experimentalists have to acquire in the course of their activities. And of course, it would be very easy to tell some horror stories certainly from my sort of physics, where background effects were not properly estimated and serious mistakes were made in interpreting. So experimentalists need that sort of skill, and theorists also need a sort of skill. Theory is always underdetermined by experiment, and therefore the theory that you choose will have to be endowed with certain meta-scientific characteristics to choose it out for the range of possible results. And one of the things that the theorists really like, and they like it because it has been found time and time again to be actually a good discriminator of long-term successful theories, is what you might call naturalness. So the theorists don't like theories that look to them to be contrived. They may be clever, but they look to be too clever by half. That's one of the difficulties, for example, that many physicists, perhaps most physicists, feel about, say, David Bohm's very ingenious reinterpretation of quantum theory. in which the unpredictabilities of the theory don't arise from an intrinsic indeterminacy in nature, but arise simply from ignorance of certain hidden factors that bring about the result. It's a very clever theory, and really put the cat among the pigeons, as we say, when he produced it, because John von Neumann had claimed to prove that it couldn't be done, and so it was quite a kind of coup to do it. Nevertheless, most of us think that Bohm's theory, though clever and instructive, is too clever by half. It is contrived. It lacks that naturalness that is persuasive. I mean, Bohm did his trick by separating wave and particle in conventional quantum theory. Of course, they are complementary aspects of the same entity. But in Bohm's theory, there are both particles and waves. The particles are as unproblematically objective as Isaac Newton himself would have liked them to be. But there is a hidden wave that encodes information about the whole environment. And that wave influences the motion of these unproblematic particles in a way that produces the same experimental consequences as conventional quantum theory. It's very ingenious, very clever theory, but it is contrived. I mean, Bohm has a wave, and so of course he has to have a wave equation. What wave equation does he have? Well, if you don't know already, you won't be surprised to learn that his wave equation is the Schrödinger equation. And where did he get the equation, Schrödinger equation from? He got it from Schrödinger. He wouldn't have got the right answers unless he put in by hand that particular equation. And that's something that really theorists don't very much like. So there are tacit skills of judgment that are both needed by both experimentalists and theorists in the pursuit of science. A very characteristic and reiterated Polanyi phrase is, we know more than we can tell. We have these tacit skills. They're not written down in a book, a handbook of how to win a Nobel Prize. They are things that we learn for a long apprenticeship in a truth-seeking community. Doing physics is like riding a bicycle. If we stop to think too much about riding a bicycle, we'll fall off the bicycle. It's a skill we possess, but we don't quite know how we possess it. There are similar tacit skills which are part of doing science. And so so science is unquestionably, in my view, an activity of persons. Nevertheless, it is a successful activity of persons. And Polanyi wrote his book. He says in the appendix, it's not in the appendix, in the introduction, he says, I'm writing this book, and he's talking about science, remember, I'm writing this book to show how I may commit myself to what I believe to be true, knowing that it might be false. That's about science, and I think that is the human condition in relation to all forms of knowledge. I think we do not attain absolute certainty in any realm of human investigation of reality. We can attain well-motivated beliefs. We can have beliefs that are sufficiently well-motivated for it to be sensible for us to commit ourselves to them. Not in an absolute sense. We know that they may be corrigible. We know we may need to change our views, but we can commit ourselves to them, knowing that they might be false. That's true in science. It's true in religion. Religious people walk by faith, motivated faith, not indubitable absolute belief, absolute certainty. The great heroic Enlightenment program of basing human knowledge on clear and certain ideas has proved in the end to be a failure. I mean, it was a noble thing to attempt. It didn't really work. The world is more subtle in that sort of way. So that seems to me. And certainly commitment is a very important word for Polanyi. He's very concerned that science involves a commitment. You know, people sometimes say, scientists doubt everything. But that's an absurd thing. We never get anywhere. If you are just paralyzed by absolute skepticism, you've never commit yourself enough to actually pursue an argument or an investigation further. Science is a precarious activity. But never, in that sense, it is not logically unassailable. Even mathematics, of course, in some sense, is not logically unassailable. Gödel has shown us that mathematical systems, axiomatized systems, including the integers, cannot demonstrate their own consistency. And if they are consistent, they contain results that are stateable within the system, but not provable within the system. Even in mathematics, that most abstract and one would think certain of the subject, truth exceeds theoremhood. We know more than we can tell. We know more than we can actually prove. That seems to be the state of affairs. So science is a precarious activity in that sense, but it is nevertheless, it seems, a very successful activity, and that success should persuade us to believe that the circularity involved in the entanglement of theory and experiment, that circularity is a benign circle and not a vicious circle. And the reasons for that, I think, are easy to see. Science just, people say, science validates itself by the long-term power of explanation that it envisages. My great scientific hero is Paul Dirac, who was the Lucasian professor here in Cambridge, and at whose feet I, with many, many people over many generations, learnt my quantum theory. And Dirac was guided in his research by what sounds like an abstract principle. It was the search for mathematical beauty. And it was because of his relentless and highly successful lifelong search for mathematical beauty that he was able to make his great discoveries. In fact, Dirac once said, as you probably know, Dirac once said, it is more important to have beauty in your equations than to have them fit experiment. Now, he didn't mean by that, of course, that at the end of the day, empirical adequacy doesn't matter. I mean, a physicist could possibly believe that. What he meant was this. Okay, you have your new theory, you've tried to solve it, you've tried to compare your solution to what's apparently going on in the laboratory, and you find they don't fit. Well, no doubt that's a setback. I mean, that's certainly true, but it's not necessarily absolutely fatal. Almost certainly, you will have solved your equation in some approximation. And maybe you've just made the wrong approximation. Or maybe the experiments are wrong. As I said earlier, we've known that happen more than once in the history of physics. So there is at least some residual hope that your theory might eventually turn out to be empirically successful. But Dirac would say, if your equations are ugly, there's no hope. They couldn't possibly be right. The whole experience of 300 years of doing physics speaks against you. The theories that really describe fundamental physics have always found to be expressed in beautiful equations. It's very remarkable that heuristic strategy, that strategy of discovery, of looking for beautiful mathematics, proves to be so successful in the exploration of the physical world. Dirac's brother-in-law, Eugene Wigner, who of course also won a Nobel Prize for physics, once said, as I expect you know, why is mathematics so unreasonably effective? Why is this abstract subject the key to unlocking the secrets of the physical universe? That's a very interesting question, which I don't intend to pursue particularly on this talk, but we can talk about it when it comes to question time if you'd like to do that. So Dirac would commit himself to the belief in the beautiful equation, but of course the justification of the beautiful equations would come in their subsequent fruitfulness. Dirac, I suppose Dirac's greatest discovery, was writing down the relativistic equation of the electron. It's inscribed, incidentally, on his memorial tablet in Westminster Abbey, if you ever go there and look for it. What the average tourist makes of it, I don't know, but there it is. And he derived that equation partly by looking for mathematical beauty, but also, of course, by desiring to combine together special relativity and quantum theory, which was a non-trivial, as the mathematicians say, a non-trivial thing to do. And he got this beautiful equation, and I'm sure he must have felt very pleased with it when he got it. But he immediately found, and quite unexpectedly, I suppose, found, that the equation automatically explains something that was already known, but which nobody had been able to understand, namely that the magnetic properties of the electron are twice as strong as you would naively expect them to be on the basis of classical reasoning. That just came out of the equation as a bonus. Well, when that sort of thing happens, you can't help feeling you're onto something. You're not just making up a pretty equation for the sake of enjoying the aesthetic pleasure of mathematical beauty. You're onto something. And of course, a couple of years later, after some difficulties with the negative energy solutions of the equation, Dirac discovers the notion of antimatter, and the positron is discovered and found to be the antiparticle of the electron, and so on. That sort of long-term fruitfulness is extremely persuasive that one is onto something. So it is the fruitfulness of physics which persuades us, I think, that physics is really concerned with a description of the physical world. There is an inescapable feeling of discovery if you work in science. Nature resists our expectations. It is recalcitrant to our expectations. We can approach nature with certain ideas in our minds, and we find that they just don't work. And nature is somehow forcing us. The nudge of nature is an indispensable part of forcing us, or I speak of course of the community, it's the really great people, geniuses of the community who actually lead this, forces us to find new ways of thinking, counterintuitive ways of thinking, which would never have occurred to us without the needful nudge of nature to push us in that direction. I suppose quantum theory is an absolutely paradigm example of that happening. Any competent first-year philosophy student in 1899 could have proved that it was impossible for something sometimes to behave like a particle, sometimes behave like a wave. After all, particles are a little bullet-like thing, wave is spread out and flappy. How could something possibly behave in those two quite contradictory ways? But of course, as you all know, that through Planck and through Einstein, people came to realize that light was not only waves, as Maxwell had shown so convincingly and beautifully in the 19th century, but it also had particle aspects. And for about 25 years, the physics community had to live with an unresolved contradiction there. I mean, nobody quite knew how something would sometimes look like a particle, sometimes like a wave. But scientists knew, physicists knew that no progress would be made by denying one half of their experience, sweeping the particle or the wave under the carpet and trying to stick with Maxwell or stick with Planck and Einstein. You have to hang on to the unexpected, counterintuitive, challenging, quotes nonsensical nature of reality by the skin of your teeth. And of course, in the end, that particular story had a very happy ending, because Dirac, again, my hero pops up, Dirac, here in Cambridge, discovered quantum field theory. And quantum field theory is an explicit example of something that does possess both wave-like and particle-like properties. It's a field theory, so it has the space-time properties that correspond to wave-like properties, but it's also quantized, and the effect of quantum theory is always to make things come in packets. What has been a continuous spectrum now becomes a discrete spectrum. You get so many packets of energy in any mode of the field, and those sort of packets are exactly like particles. You count up the amount of energy by counting the number of packets you have, counting the number of particles that you have. So that the apparent paradox of wave-particle duality was fully resolved by quantum field theory. But people wouldn't have got there without the stubborn nudge of nature, the resistance of nature to our expectations. J.B.S. Haldane was a very distinguished biologist, writing towards the end of the 1920s about the discoveries of his physics colleagues, said that it seemed to him that not only had the universe turned out to be queerer than we thought, but it turned out to be queerer than we could think.
Yeah.
We wouldn't have found these counterintuitive ideas without the nudge of nature. And that's one of the reasons why I think that physicists and scientists generally are instinctive realists. They do think there is a world out there which we encounter, which impinges upon us, which shapes our thinking about it. It's not a question of confabulation, making up pleasing stories that we like to tell each other. There is a resistance of expectation in nature that makes us take a realist view of scientific discovery. And that realist view can also lead to and accommodate the acknowledgement of unseen realities. I worked in particle physics during the 25 years. It was a very interesting period to be on the subject when the standard model of the quantum theory of matter got established. When I was a young research student here in Cambridge, we thought that matter was made up of protons and neutrons. By the time I left the subject, at the end of the And in the 70s, the dust had settled, and we all knew that matter was composed of nuclear matter was composed, the protons and neutrons were composed themselves of yet more fundamental constituents, the quarks, of course. Now, of course, nobody has ever seen a quark, a single quark on its own. We believe them to be confined, that is to say, they are so tightly, so strongly bound together within the particles they constitute, but even the most energetic impact will not succeed in dislodging one of them. So quarks are essentially unseen realities. But we believe in them, I mean, in a more drastic way than say, electrons are. I mean, you don't quite see electrons directly, but at least we see traceable signals of electrons, but we don't see traceable individual signals of the existence of quarks. But we believe in the reality of quarks, essentially because they make sense of great swathes of more directly accessible experience. The patterns in which the observable elementary particles are ordered. They have certain beautiful orderings and patterns among them, and those patterns are exactly the patterns that would result if those particles were made up of quarks. Then there are also experiments called deep inelastic scattering, where you have a very high energy projectile hits a proton and bounces back. It's greatly deflected by its impact, rather than just whizzing through it, as you might expect. That's a phenomenon that recalls a fundamental experiment by Rutherford and his collaborators in about 1910, when they scattered alpha particles off thin filaments of gold, and again they found that some of those alpha particles bounced back. And you may remember that Rutherford said it gave him as much surprise as it would be if a 15-inch naval shell had bounced back from hitting a sheet of tissue paper. And the interpretation that Rutherford produced was that they were not pushing through a plum pudding model of the atom, as J.J. Thomson and people have thought, a sort of mass of positive charge with a few currents of electrons thrown in it. They were hitting some very tiny, hard scattering center in which all the positive charge of the electron, the atom, was concentrated. Rutherford had, of course, discovered the nucleus. I mean, a very, very great discovery in the history of science as well. Well, similarly, these much higher energies, these deep inelastic scattering experiments, many of which were done at Stanford, power particles projectiles bouncing back, electrons bouncing back. And these could be interpreted as that they were interacting with small, hard scattering centers inside the proton itself. When you analyze a whole series of these experiments and put them all together to see what sort of patterns were emerging from it, you saw that these little hard scattering centers, again, would have exactly the properties, the fractional charge, for example, exactly the properties that quarks were supposed to have. So these indirect observations of particle patterns of structure and of deep inelastic scattering were made sense of by the assumption of the unseen reality of quarks. And that means to say, I think, that the inclination of scientists, of fundamental physicists anyway, is to see the key to reality as lying in intelligibility. A belief that makes sense of the world is to be taken not as just a pleasing story that just happens to fit the facts in an agreeable sort of way. It's seen as being a signal of some ontological reality that's been encountered in that way. It's not inevitable to do that, of course, but it's a very natural, highly persuasive way of talking about it. So intelligibility is the key to reality, to the nature of being, it seems to us. Things that make sense of great swathes of experience are to be taken with ontological seriousness. That's a theme that resurfaces very much in theological thinking in relation to knowledge of God, particularly theological thinking that falls in the Thomistic tradition stemming from Thomas Aquinas. Bernard Lonergan, one of the great theologians of the middle of the 20th century, wrote a book called Insight. And the message of that book is that intelligibility really is the key to reality. And that's a point of view that I find very congenial to me as a scientist. So all this adds up to a picture of science as being, as I say, a subtle activity, to some extent a precarious activity, nevertheless an activity to whose results we commit ourselves and trust ourselves. And this leads to the notion of critical realism. And both words are important in that. Realism, the noun, says that the science is investigating a physical world that is out there, that is over against us, if you like, whose reality is constraining our experience of it and our thoughts about that experience. But it's critical realism. It's not a naive objectivity. We don't just look and see. We don't see the quality, they're unseen reality. It's critical realism, and it requires inference and a degree of commitment. It's not presented. It does not present us with knockdown arguments that are necessarily true beyond any peradventure, but it presents us with well-motivated arguments and insights which make it persuasive that one is onto something. That's what we mean, I think, by critical realism. Science, in other words, is verisimilitudinous. As I say, it gives us reliable but always partial knowledge of the world. We never utter the last word in our scientific investigations. Protons and neutrons didn't turn out to be the last word. Quarks and gluons came along as a further word. It may be, or it may be not, it may be that strings are a further, more fundamental word beyond quarks and gluons. We never have a complete grasp of the nature of physical reality. But we have a grasp, we know enough of a certain well-winnowed regime, a certain domain, say, of energy or whatever it may be, which has been well explored. We know enough about it and have a sufficient motivated understanding of what's going on in it, and for us to commit ourselves to that as an understanding of the world. But it won't be the last word. Science, if you like, makes maps of the physical world, and those maps are reliable on the scale on which they're made. But of course, no map tells you all the details of the terrain. And the map you need and can rely upon depends upon the purpose which you want to rely upon. If I want to get from Cambridge to Oxford, I can have a motoring map in which the two cities are represented by dots, big black dots on the map. I want to negotiate my way around Oxford, I need a map on a different scale. I need a street map of the city. So I think that science makes maps of the physical world, which are reliable, but which are not the total story. So the achievement of science is, in my view, well-motivated understanding, but never actually absolute truth. In fact, I think absolute truth is not really attainable in any form of human investigation reality. I already pointed to the extreme example, in the sense of mathematics and the question mark that Gödel's theorem places over that. That's it, seems to say. Right, now what about realism? Well, many of my scientific friends, who are not believers, are both wistful and wary about religion. They're wistful because they can see that science doesn't tell you everything. They're not scientific fundamentalists. Some of them are, but most of them are not scientific fundamentalists. They see that science tells you things that are very well worth knowing, but they don't tell you the whole story. It brackets out issues of meaning and value and purpose, things of that nature, which is its great heuristic strategy, its great way of answering the questions that it allows itself to ask. But that by no means implies that there are not other questions to ask, necessary to ask, meaningful to ask, which are simply beyond science's self-limited power to investigate. I mean, science has purchased its great success, it seems to me, by the modesty of its ambition. And so many of my friends can recognize that, and they would like a broader and a deeper view of the world. And they can also see quite often that religion would offer such a view of the world. It obviously deals with lots of things which are bracketed out from science. However, they're not only wistful about religion, but they are wary of religion. And they are wary of religion because their picture of religious belief is that it is based on submission to an unquestionable authority. You shut your eyes, you grit your teeth, you believe 6 impossible things before breakfast, because some unquestionable authority, a book, a person, a community, tells you that's what you've got to do. And of course my friends don't want to commit intellectual suicide, and neither do I, and I'm sure neither do you. And what I'm always trying to do with my friends is to persuade them that there are motivations to my religious beliefs, just as there are motivations to my scientific beliefs. Of course, there are different kinds of motivations, because there are different kinds of beliefs. I already said that science treats the world as an object, as an it. Religion, of course, is concerned with a much more personal domain of experience, indeed a transpersonal domain of experience, of encounter with the sacred reality of God. And that means that its questions, its answers, its methods of seeking understanding will be different, but they will be there. And for example, speaking from a Christian point of view, the Bible is not a divinely dictated textbook conveniently provided for us where we look up all the answers. It's not a textbook at all. It's much more like a laboratory notebook. It's a record of an indispensable record, in my view, of human encounters with a sacred reality, both in the history of Israel and in the life, death, and resurrection of Jesus Christ, and the immediate aftermath of that. And it's to be read in that sort of way. And of course we have to figure out whether those accounts are reliable or not, whether there is some reality that lies behind them, whether they are just confabulations, and we have to figure out that if they are reliable in some way, what that means for us. So it seems to me that in that sense religion is as much concerned with the search for motivated belief as science is, but the motivation is different. There are no experiments to be done in religion, indeed in any form of personal encounter. If I'm always setting little traps to see if you're my friend, I will destroy the possibility of friendship between us. It can only be based on some degree of mutual trust. And that's true between you and me. It's even truer, I think, of our relationship with God. No good standing up and saying, if God's there, let him write me a message on the clouds or strike me down dead or whatever you want to say. God just doesn't play those sort of silly games. And so there has to be a different form of seeking belief, but they are nevertheless motivated beliefs. Let me just very briefly and inadequately really sketch what might be some of the motivations for those beliefs. First of all, some of them I think will come from looking at the world in a general sort of way. It's called natural theology. Natural theology is the attempt to learn something of God from general experience and the inspection of the world and from rational consideration. It's a limited form of inquiry, obviously, but it's nevertheless a worthwhile thing to do. And one of the important aspects of natural theology actually arises from taking seriously what science has to tell us about the world, but going beyond science's power to discuss what's going on. We're concerned with what you might call meta-questions, questions that arise from the experience of doing science, but which are not scientific in their character. I think we have every reason to believe that scientifically posable questions will receive scientifically statable answers, but we equally have every reason to believe there are important questions to ask, necessary questions to ask, which are not scientific in character, and some of them arise from our experience of doing science. And just to give you a quick example of that, one is, why is science possible at all? Why can we understand the world in which we live? You might say, well, of course, evolutionary biology explains that for us. If we couldn't figure out that it's a bad idea to step off a high cliff, we wouldn't stay around for very long. And of course, that's obviously true. We have to make rough and ready sense of our everyday experience. We would stay around a bit longer in East Anglia than we would in most parts of the country, but we wouldn't stay around forever. But our power to understand the world, our scientific power to understand the world, of course, is vastly beyond anything that is necessary for everyday survival, or it seems to me can plausibly be considered to be a happy accidental spin-off from the necessities for everyday survival. It's one thing to figure out it's a bad idea to step off a high cliff. Quite a different thing, it seems to me, when somebody like Isaac Newton comes along and sees a great creative leap of the human imagination, sees that the same force that makes the cliff dangerous is also the force that holds the moon in its orbit around the Earth, and the Earth in its orbit around the Sun, can discover the mathematically beautiful law of universal inverse square law of gravity, and in terms of that, explain the behavior of the solar system. We don't need that for everyday survival. By any chance you're a Sherlock Holmes fan, you may remember that when Holmes and Watson first meet, they're having a conversation, and Holmes is pulling Watson's leg, I think, from the start, and he says to Watson, I don't know, does the sun go around the Earth, or does the Earth go around the sun? And the good doctor, of course, horrified at his apparent ignorance on the part of the great detective, and Holmes said, what does it matter for my daily work as a detective? And of course it doesn't matter at all, but we all know many things we don't need for our daily needs. And like you say, we can explore a counterintuitive world of quantum theory, despite the fact that it's totally different from that clear and reliable world of every day. And why is mathematics so unreasonably effective? Why is this abstract subject, which doesn't seem to have any connection particularly with the world in which we're, why is that the key to unlocking the secrets of the universe? These seem to be questions that are worth asking. They're significant facts about the world in which we live, that we can do science, that mathematics is the key to unlocking so many secrets. And it would be entirely intellectually lazy just to shrug our shoulders and say, gee, that's the way it happens to be, and a particular luck few chaps are good at maths. I mean, it would seem to be pretty supine, pretty lazy thing to do. I don't say this is a knockdown argument, but a religious understanding of the world offers one explanation of all of these things. Because I've been describing a world in mathematical terms as a world shot through, if you like, with signs of mind. And a religious point of view would say that it is the capital M mind of the Creator that lies behind the wonderful order of the world. And we are able to penetrate it because, to use an ancient and powerful phrase, we are actually creatures made in the image of the Creator. We have given those powers to do that. You're not stupid if you don't accept that, but it's to me, it's a well-motivated and illuminating way of thinking about it. And of course there's also the fruitfulness of the world. I mean, the wall starts 13.7 billion years ago, expanding almost uniform ball of energy. Other worlds, the home of saints and scientists. It's not. Might suggest that something's going on in the history of the universe. It's not just one damn thing after another. It's somehow going somewhere. Or so it seems to me. And of course we all know that fertility is only possible because of certain inbuilt characteristics and the actual given physical fabric of the world, something we'll think about tomorrow. I won't go into that anymore. So, but if the universe is purposeful in its appearance, then that might be a reflection of the divine purpose behind it. So a natural theology, that sort, at least puts God on the agenda. Both the possibility that believing in God might be a well-motivated belief in relation to that, but it would only give you a very thin notion of the nature of God. You would see God as the cosmic architect or the great mathematician or something like that. It would be as consistent, for example, with the deistic God who simply sets the world spinning and then stands back and watches it all happen, as it would be with the God of theism, the God that the three Abrahamic faiths, for example, speak of, Judaism, Christianity, and Islam, a God who is concerned with the world and interacts with the world and with people in the world. That God doesn't necessarily come out in that sort of general abstract form of consideration. If there is such a God, we'd have to look for another source of insight and motivation for belief in that. And that takes us from natural theology to revelational theology, the claim that, in fact, God has acted to make God's nature known in various acts of encounter with sacred reality in certain communities and certain people in the course of history. And that's something, of course, that is outside the range of science, but is not outside the range of consideration by people who recognize themselves as being persons. All forms of personal knowledge are unrepeatable and have unique characters to them. You never hear a Beethoven quartet the same way twice, even if we play the same disc. And so it can be unique and uniquely illuminating moments of encounter with divine reality. And Christians, of course, believe that those encounters are particularly found in the history of Israel and the life, death, and resurrection of Jesus Christ. Now, I a long talk about that, but just to illustrate one conceivable, one example, there's something to think about there. It requires care, it requires scrupulousness. The pursuit of truth is absolutely important to religion as it is for science. Religion is not simply in the business of making you feel happy or confident or that sort of thing. You can only, or unafraid at the approach of death. You can only do those things if it's actually true. So the question of truth is as important to religion as it is for science. Now, central to my Christian belief is the belief, for example, that Jesus was actually raised from the dead the first Easter day. That's a pretty counterintuitive belief, to say the least of it. But here's a possible start to think there might be something to look into there. If you think about Jesus and you compare him with other great religious leaders, there's obviously something in common. They all say wise things, they're all credited with remarkable deeds, they all have a charismatic power to attract followers and influence them. But there's one respect in which Jesus is certainly different from Moses or Buddha or Muhammad, for example, and that is that all those other great religious leaders die in honoured old age, surrounded by their disciples who are resolved to carry on the work and message of the Master. But Jesus dies in midlife, deserted by his followers, a painful and shameful death, a death incidentally that any first century Jew would see as a sign of God's rejection, because it says in Deuteronomy, "Cursed is anyone who hangs upon a tree." So Jewish people had a horror of crucifixion for that reason. And the two of the Gospel writers, Matthew and Mark, are honest enough to record that in that dark event, there came the cry, my God, why have you forsaken me?" I mean, it's a pretty miserable ending for what had been, no doubt, a rough and fruitful life. It looks like a scene of defeat. That Jesus was perhaps, in the end, just another pseudo-messiah. There were quite several of them in the first century who had pretensions above his status and got his comeuppance and that sort of thing. And if I think the story of Jesus finished like First Good Friday, I think we would never have heard of him. I think he would have just disappeared from history, like the other pseudo-messiahs have done. I mean, scholars know about them, but nobody else does. But we all know about Jesus, and his story continued in quite an unexpected way. Something must have happened to continue it. And you have to look into what that might be, or all the writers of the New Testament think that it was a resurrection. But you have to look into that carefully, and so on and so on. So that's just an example of how motivated belief might arise in a religious context, even though the motivations are obviously more specific and different to their character than those who refer to the sun. And I would say, I would go back to the comparison with the quarks. We believe in the unseen reality of quarks because they explain great swathes of physical experience. I would say we believe in the unseen reality of God because that explains great swathes of spiritual experience. Makes intelligibility intelligible, the intelligibility of the universe intelligible, and I think corresponds to widely testified experience of encounter with sacred reality. So that would be an example of how motivated belief plays its role in religion, and therefore I think that critical realism is as applicable a concept to religious belief as it is to scientific belief. And of course, the realism is the claim that there really is a sacred reality which is being encountered. The criticality is even more critical, of course, in the case of religion, for the reasons we've just been considering, but it is there. It is not unmotivated. It's not a question of believing fairy stories because they either because we're told to do that or because it seems a comforting thing to do. There is real motivation for it. So much motivation that many of us are prepared to bet our lives on that. There's a great tradition in Christian theology, which is the Thomist tradition I've already referred to, which essentially I think says that if you are searching for truth without reserve, quite prepared to follow evaluated experience wherever that may lead you, then you are seeking God whether you know it or not. And the end of that search will be the encounter with God. And I go back to my friend, this is one of my favourite quotations, which is a quotation from, I say friend, but I never met him, but I mean a friend through reading his books, Bernard Lonergan. And in his book Inside, he says this. He says, God is the all-sufficient explanation, the eternal rapture glimpsed in every Archimedean cry, of eureka. I love that quotation. And it speaks to both the scientist and the Christian believer. So I think critical realism is a pretty useful idea. And I think it covers the two main interests of my life, which are science and religion.
Thank you, John. Well, we have plenty of time for questions. Perhaps I'll kick off with one before we throw it open. Yeah. Can you just reflect on what the cosmologists, at least, are telling us now, when they say that we really don't know anything about 95% of stuff they call dark matter?
Well, that's another unseen reality. We believe it's there because we can see effects that are interpreted that way. As far as dark matter is concerned, of course, it's the gravitational attraction that seems to be hold together galaxies or systems of galaxies that are rotating and are rotating too fast for gravity unaided to hold them together. And we believe in dark matter because people believe that they have discovered that the expansion of the universe is increasing, accelerating. Dark energy, I'm sorry, yeah. Thank you. Dark energy is accelerating, and an explanation of that would be through dark energy. And dark energy is an energy associated with space itself, and if it's positive, then that means that there is a drive, a pressure to drive expansion. So that's another example of unseen realities. At the moment, of course, we are in the sort of hanging on by the skin of our teeth phase about these things. We don't know what the either dark matter or dark energy might be, or where its origin. But it wouldn't be sensible again to say, well, that makes sense. Let's throw it away.
I guess it puts a cap on the hubris of human endeavour, which makes us think we know everything, doesn't it?
Well, I think if science does teach you anything, it does teach you that you don't know everything.
Yeah.
The world is surprising. That part makes science interesting. If you don't know what you're going to find around the next corner.
Yeah. We'll go there and then. Yeah.
Going back to your interesting discussion of Dirac and Beauty and equations, are you familiar? Is there any modern theology of mathematics or theology of physics?
Well, people do think about it. Yes, there is. In fact, I've been involved in a little sort of consultation about the nature of mathematics. It's not particularly theologically oriented, but there are theological questions. See, that's another interesting question. What's the nature of mathematics? Is mathematics discovery, or is it invention? Do our mathematical friends just make up pleasing intellectual puzzles which demonstrates their skill to the rest of us? Or are they actually exploring a world of mathematical reality? And most mathematicians think that it's discovery and not just not invention. And that there is, and therefore they're in some sense Platonists. They believe there is a realm of mathematical entities that we're able to explore in that sort of way. Now that realm might be a realm held in the mind of God, and I suppose that's what Augustine, for example, was thought of it to be. But it does at least lift our metaphysical science a bit. If there really is a realm of mathematical entities that we're exploring, then the material is not the whole story, for example. It's just a slight sort of nudge in the direction of an enlarged metaphysical view of the world. And that's about it. There's a famous quotation in the Wisdom of Solomon that says that God ordered everything by number something or something. Measure. Thank you. I knew you know that. That was appealed to in the Middle Ages and farmers in support of the idea that mathematics had a role in explaining the nature of the created world.
Yes, I just wanted to ask a question while we're on the subject of dark matter.
Right.
Can anything be deduced about its nature from the fact that it high density on the scale of galaxies, but not on the scale of stars and planets? So you don't get dark matter stars.
Yeah.
But I just wanted to know if something could be deduced.
Well, yes, that's a good point. I mean, obviously it probably had to be consistent with that observation. And one of the candidates for dark matter are these weakly interacting massive particles, and they wouldn't be as densely distributed, obviously, as ordinary matter. But because they're massive, they would be able to produce on large-scale effects. I mean, I'm no expert on dark matter, but that seems to me would be the situation.
We have cosmology lectures tomorrow. Let's go ahead.
You mentioned that it's important to be scrupulous in proceeding towards the truth, and
Absolutely.
it seems that in science that some of the procedures have already been fairly well worked out. Scientific institutions, peer-reviewed journals, that kind of thing. How would you suggest we proceed in the search towards religious truth? It seems that's far less well worked out. Individual reflection versus the authority of the Pope. Many other ways of proceeding. Do you have an idea?
Well, it's a much more, science is subtle enough, but it's a much more subtle activity, obviously. And what I'm suggesting is that it isn't based on finding some unquestionable authority who tells you all the answers, whatever that authority might be thought to be. But it is involved in evaluating experience. I like to, as a scientist, I like to describe myself as being a bottom-up thinker. That's to say, you start from experience, the basement of experience, try and move to the first floor of interpretation and understanding. There are top-down thinkers who start on the 10th floor of self-evident general principles, which often turn out to be neither self-evident nor general, and descend to particularities. I think there's scope for both forms of thinking, but a scientist is naturally a bottom-up thinker. And I want to approach my religious belief in a similar sort of fashion. So what I have to look at, as I say, I see the Bible, for example, as the laboratory notebook of Jewish and Christian experience, and I want to suss that out. I mean, not everything. I mean, it's not just a plain, straightforward thing. Sometimes there are stories, there's history. You have to figure out what poetry, prose. You have to figure out what you're reading. You have to do that sort of carefully, and you do that in again within a truth-seeking community, which for the Christian is the community of the church, and you do that also, of course, in relation to your own personal experience, weak and limited though that will be. But nevertheless, these things come in. So in general terms, it's not all that different, but in particular terms, it obviously is, because, as I say, the one thing you don't have is the reiterative recourse to experiment. And though it's possible to say to somebody, you can commit yourself in faith and see how that works out for you, you can't guarantee how that's going to work. People have to make personal discoveries. But again, within a truth-seeking community, I think it's very important that that's the case. And the truth-seeking community for religion, all religious traditions actually, is spread out throughout time. I mean, science is a very synchronic, as people say, activity. Science is by and large linear, it accumulates. I mean, any physicist today knows much, much more about the universe than Isaac Newton ever did, simply by living 3 centuries later than that great genius. And you read the textbooks and there it is. Religion is different that way. The insights of different generations will be different from each other. I mean, I'm myself very much helped by the writings of 14th century English mystics, people like Julian of Norwich and the unknown author of the Cloud of Unknown. Now, if these people had experience and insight that we shall only gain even small access to by apprenticing ourselves to those insights. So it's spread out. That's why the great figures of theological thinking, for example, Augustine, Aquinas, and Luther and Calvin, they're all still part of the conversation in a live sort of way, in the way that Newton and Maxwell, great people though they are not really in the same direct, personal way, part of the conversation of physics.
Three things actually, three very short things. I think the scientist W.H. Bragg said that Christ was the great scientist because he didn't command us, but he asked us to go and experiment with his instructions. And secondly, do you think is that fair? Do you think, and the second one was, do you think that it's fair to see...
I'm a bit deaf.
Sorry.
I have to come listen a bit closer.
I just said the scientist W.H. Bragg said that Christ was the greatest scientist because he asked us to experiment with his instructions and try for ourselves. I don't know what you think of that. But this also, do you think it's fair to see science as a form of worship? And lastly, I was wondering if you could repeat the quote by Bernard Longman.
Okay. Well, I certainly, as I say, I'm a bottom-up thinker. And so I certainly think that there is an indispensable experiential aspect to religion. But religion, you can't do it because it involves personal and transpersonal encounter. You can't do it in a purely detached view, suck it and see point of view. To some extent, you have to commit yourself, knowing that it might be false, in the Polanyi phrase. So that is much more true, obviously, of religious experience, or indeed anything in between. I mean, it's a bit. I mean, just think about, say, human aesthetic experience. There's no experiment that demonstrates that Bach's Mass in B minor is the greatest work of art. Nevertheless, and so on. So that's the first point. Second point was
Whether science is a form of worship.
oh yes. Well, I think it is actually a very important word in the discourse of scientists, but not, of course, in the things they write for learned journals. The very important word is wonder. I mean, doing research in science is very hard work. There's lots of frustration. As the good ideas in the morning prove less persuasive in the cold light of the afternoon. There's a lot of wearisome routine, as there is in every worthwhile activity, and so on and so on. So it's hard work. The reward for that hard work, from time to time, is the feeling of wonder at some new, remarkable aspect of the world that is revealed to inquiry. Usually, of course, revealed to the community. I mean, personal discoveries are pretty minor. And that the experience of wonder is, I think, actually an act of worship, whether the scientist knows it or not. It is, in fact, worship of the creator whose mind lies behind the marvellous order of the world. But many scientists have, and some example, I mean, Richard Dawkins, for example, is very emphatic in his more recent writing on Weaving the Rainbow and so on, that the one, he doesn't want to dispense with wonder, but it's very important to him. So I think, given his given his reductionist metaphysic, it's hard to see exactly where wonder finds a logic in his account of reality. And the final thing is the Loringer thing. The Loringer quote is, "God is the all-sufficient explanation. The eternal rapture glimpsed in every Archimedean cry of Eureka." Loringer was good at purple prose.
Have a question over here, then we'll go to the back.
I think it's more difficult to believe if there is a fact you cannot see or prove, or there is a reason you cannot see or prove. And what is easier to explore if it's going for science?
Well, I'm suggesting that, in fact, proof, if you mean by that absolute certainty, 100% guarantee, is something that nobody has access to in any worthwhile aspect of their life. That the nature of human knowledge and the nature of human life is that it is more precarious than that. That doesn't mean to say we haven't unmotivated beliefs. We haven't beliefs that are sufficiently well motivated for it to be rational for us to commit ourselves to them. But I don't think that we have certain. I mean, I know a mathematician in North America who thinks that arithmetic is probably inconsistent. Most of us don't lie awake at night worrying about it. I mean, I may be wrong about that. That's what I'm suggesting to you. Of course, there are degrees. I mean, it's very easy to believe in arithmetic. It's much more difficult to believe in various forms of religious belief and all sorts of things in between. And all of us, of course, are constricted by the perspective that we have on the world. We see some things from a way we look at things and other things we won't be able to see. So there's lots of uncertainty there. But I go back to my second favourite quote, which is the Polanyi quote: "I may commit myself to what I believe to be true, knowing that it might be false." So remember, it's science that he's talking about.
Yes, the back.
I wonder if the role of experience in science and religion might be a little closer. There might be a little more similarity than you're allowing. So that it's a bit more. It can be a bit more like experiment, in the sense that in the religious case, someone on the cusp of conversion, say. I think a very typical sort of and honorable sort of thing to do is to pray in a sort of experimental way. To pray.
God, if there is a God.
Yes, exactly,
Yeah.
And that God honors that for many people anyway, and that it isn't that doesn't make the relationship an impersonal one. And then on the flip side, I think in the case of scientific programs, especially cutting edge sort of science, it's not clear that string theory is going to pay off
I'll talk about string theory tomorrow.
by any means,
Yeah,
you know.
yeah.
And yet it's probably a good thing that some people are committed to it in the sense that they have a hunch that it's right, and this hunch is sort of necessary in order to keep them going, and we'll never find out unless people sort of say, well, this seems pretty good, and then they build a lab. We'd never know if they didn't sort of launch out into the deep a bit.
Well, thank you for those. I accept those qualifications, but nevertheless, I think there is a distinction. See, because we transcend the physical world, we have great powers of contriving what we want to happen. Because God transcends us, we can't contrive how God will react with us. And there's a very strong tradition, for example, in very strong spiritual tradition, which recognizes, if you like, the ambiguity of encounter with God. That there are long desert periods where God seems far away from people. And with certain hindsight, people can see that perhaps it's being tied actually with spiritual growth because they hold on to God, but they're not comfortable periods to live through. That's very well documented in the spiritual literature. And again, there's great ambiguity about, say, praying for things. I mean, so somebody is very ill, apparently dying, and the local church or mosque or synagogue, whatever it may be, prays for that person, for healing for that person. Now, healing may come through some hoped for period of remission. But it may come for that person being able to accept the imminent destiny of death. Nobody can say beforehand which it's going to be, and nobody actually say afterwards whether that was healing, except the person or those who are very close to him or her. So there is just, again, I'm back to, religious judgments are much more like aesthetic judgments than like scientific judgments. I mean, there are motivations for thinking something is a great work of art, but you can't. Sometimes you can see it, sometimes you can't. But I agree that the too black and white a separation is not very helpful.
If you had been born in India, Mr. Polkinghorne, would your critical realism not have led you to become a committed Hindu?
Well, that's a very fair question. Let's sharpen it up a bit by saying, have I been born in Saudi Arabia? Will I surely not have grown up a Muslim? And the answer is, surely I would have done. But who can say what my subsequent life would have been? But I mean, it's pretty clear that's what I would have grown up. But it's also clear, of course, that if I'd grown up in Saudi Arabia, it's very unlikely, I think, or certainly much less likely, that I would have become a theoretical physicist. so undoubtedly, origin affects these things. But we mustn't commit what I believe philosophers call the genetic fallacy, which is thinking that origins explain the actual nature of what's behind it. But I think there are two great problems for religious belief. One is the problem of evil and suffering in the world, theodicy. I might say a little bit about that tomorrow, I'm not sure. But the second problem is the diversity of the world faith tradition. And it's very, very puzzling because, first of all, I think it's fairly clear to me that all of them are speaking about the same realm of human experience, which we could call encounter with the sacred. Some of them express that in theistic terms, some, of course, in non-theistic terms. But there's a recognizable cousinly relationship there. And these days, of course, people in other faith traditions are not odd people in faraway countries who believe peculiar things. They're our neighbours, they're down the street, and we can see the spiritual authenticity of their lives. So we can't say, we know everything, they know nothing. On the other hand, they say such very different things about the nature of reality they encounter. I mean, is the human person an entity of abiding significance in the sight of God, which is what the Abrahamic faiths all say? Or is it something that's recycled through reincarnation, as our Hindu friends will? Or is it ultimately an illusion from which the Sikh believes, as the Buddhist doctrine of Anatta seems to say? These are very, very sharp contrasts. And realism is pretty unnerving, I think, for a scientist, because though science started in Western Europe, 17th century or whatever, it's now worldwide. You stop somebody in the street in London or Delhi or Kyoto and ask them what matter is made of, provided you stop the right person, they'll say quarks and gluons. You stop three people in those three cities and ask them what's the nature of outer reality, you're going to get a very different answer. And I mean, that is a puzzle. I mean, obviously culture comes into it. Obviously cultural context of things like nature come into it. And obviously nurture, the way that you allude to, comes into it. But there's a problem. It troubles me quite a lot, I must say.
It's just that the same arguments that you used,
Yeah.
if you were really committed to critical realism in science and religion, were you born in a different country, could have led you to argue just as fervently for another religion. It seems to me. Could have led you to argue for the validity of another religion than Christianity.
Yes. I think in rather different terms. I think a Buddhist would argue in rather different terms to the term which I argue, but yes. Yes. Well, I don't have a. I think this is a very important item on the contemporary theological agenda, and I think it will be there for a long time. Not the 21st century problem, the third millennium problem. Because conversation is just beginning. Real conversation is just beginning to take place, as far as I can see, between the different religious faith traditions, and it has to start at the periphery. It's no good saying, okay, today we talk about Jesus, tomorrow about the Quran, so on and so on. Such a head-on onslaught puts the defences up straight away. So you have to approach it a bit obliquely. And it's actually asking the different faith traditions what they make of modern science. It's quite an interesting, worthwhile thing to discuss. You know, there was a project about 10 years ago called Science and the Spiritual Quest that I was lucky enough to take part in. There were 4 groups of 15 scientists. The phase I took part in, they were simply from the Abrahamic faith. There was the later faith. The later phase was with more worldwide participation. Each group, the participants had the same science in common. I was in the physics group, of course, but they came from the 3 different faith traditions. And it was interesting. I mean, we didn't get too far, but we learned a bit about each other and a bit of respect for each other from that encounter. And I think to some extent it's very positive.
Is there any aspect of top-down thinking that you think might be salvageable or useful?
Well, that would be rather presumptuous of me to say that, I think. One way or the other. I mean, I am constitutionally leery of top-down thinking, because so often within the limited realm of science, what seemed to be self-evident, unquestionable, has turned out to be need a revision. And I mean, take some very crude and early examples. I mean, the fixity of the Earth or the fixity of species, for example. And people found, of course, that when we had good reason for not believing either of those statements, it didn't really destroy religion, but religion had to revise its thinking. So, but I don't wish to speak slightingly of top-down arguments, but I must say, most of the top-down arguments I hear, I suppose, are by English-speaking people in the analytic philosophy tradition, and they are quite surprisingly intellectually confident, and a way that I cause my eyebrows to go up occasionally.
Yeah, I worry a little bit about using the same term, critical realism, for both science.
Yeah, I know you do.
And
Yes.
the reason we have been through this before. I want to put it in a slightly different way at the moment. But I mean, my initial worry is that it leads to expectations that the criteria ought to be somewhat the same in both. In other words, critical realism in science is going to carry over. You're going to apply something like the same criteria. But let me make this a little more specific. In the case of science, the whole notion of critical realism depends on a set of criteria that have developed over the last 300 years. For example, intelligibility by itself, in the case of Descartes, did not work out. Intelligibility, his system, his principles of philosophy is admirably intelligible, but of course it's dead wrong.
Yeah,
Okay,
yeah.
so intelligibility as a criterion is very important but not sufficient.
Yes, yes,
Okay,
of
so
course, yes, yes.
there's a
absolutely.
whole, there has been a long development of criteria that constitute the word critical in the context of, and that set of criteria, and I think that I absolutely agreed with your very good development of that, because I think the notion of fruitfulness is going to be critical and going to be crucial there. Now, it doesn't seem to me that we have developed anything like the same tradition of criticality in the context of religion. In other words, I'm worried about the applicability of the term critical if one is going to expect something like that history of testing of criteria.
Well, thank you, Aaron. I see the point you're making. And I see a cousinly relationship between the search for truth in science and the search for truth in religion. And I see that cousinly relationship expressed in terms of the search for motivated beliefs. And I agree that the character and evaluation of the motivations are pretty different in the two areas. So I would certainly go along with that. And I mean, at the end of the day, science is easy and theology is difficult. Relatively speaking.
Says a scientist. A theologian might put it the other way around.
No, I don't think so.
If I may, John, on a similar thing again, I felt the expression unseen reality. I mean, I think the analogue is very strong and very powerful, but it's kind of incomplete as well, because what we mean by unseen reality, it seems to me in science, is a little bit different from what is meant by it in theology. For example, in the just to stick to the example you used so very well, I think in case of the quark, the reason somebody in New Delhi or Moscow or New York will agree is precisely because the indirect evidence is so very compelling. And in other words, that there aren't lots of different quark theories, let's say, or competing theories at this stage, because everybody has more or less agreed that this indirect evidence, indirect though it may be, does point in a certain direction. And where the analog is incomplete is in religion that's not true, in that there doesn't seem to be a consensus or even a drive towards consensus between the different religions on what they believe to be unseen reality. Apologies if it's the same question again.
Well, I accept that point. That is puzzling, and so on. The reason that intersubjective agreement is, comparatively speaking, easy in science is connected with impersonal repeatability, and we obviously don't have that. There isn't. But again, I mean, I think it's quite useful to not to just concentrate on science and religion, but to think of intermediate things between. I mean, take aesthetic experience. I mean, Western music is one thing, Eastern music seems to be another thing. I don't doubt for a minute that both have their own validity, but it's, as an untutored and ignorant sort of person, it's quite hard for me to come to terms with various forms of Eastern music. So, there is bound to be a much larger cultural and personal dimension in assessing motivations in relation to religion, or pretty well any form of human personal activity, but religion, because of the transpersonal character of God, religion is right at the end of that scale. I agree about all those things. Nevertheless, I do think there is a sort of cousinly relationship. I suppose I'm particularly keen to prophesy against the feeling which is so often asserted by our more strident atheist friends at the moment, that religion is simply irrational fideism. Believing in God is like believing in fairies at the end of the garden. Not many people get converted in midlife to believing in fairies at the end of the garden, but people do get converted to religious belief in midlife sometimes.
My first question concerns your comment on theology and physics, which was taken up by Barry. You speak of critical realism of reality beyond the material.
Yep.
So won't that make abstract mathematical objects co-eternal with God? That's the first. The second concerns application of Gödel's theorem in physics or any other field, because we have these two contrasting positions. First one, Theodor Frankl, in his book An Incomplete Guide to Gödel's theorem, its use and abuses, he was vehemently against extending Gödel's theorem from the system of logic in this thing, mathematics. And you have Stanley Jackie, who says that even though Gödel's theorem is there, we can derive a final theory of everything in physics, but we'll not be able to know whether that's the final theory. Because in the end of the day, I think it's the quest for certainty, that's the underlying motivation for.
Well,
Can you explain what Gödel's theory is as well for those of us who may not know?
Well, I did sort of briefly mention in part. I'm no expert on it, but if you take a system, an axiomatized mathematical system, which includes the integers 1, 2, 3, 4, by a very, very clever self-reference type of argument, Gödel showed that that system is either inconsistent, or there are statements that you can see are true. This is the famous Gödelian sentence. You can see are true, but cannot be established within the argumentative framework of that system. It's one of the big discoveries of intellectual history of all time, it seems to me. So it means mathematics is as I say, it means among other things that mathematics is inexhaustible. Even the integers are inexhaustible. There are properties of the integers that we never have enough of them to characterize the whole system. So and all these things, I simply want to look at that simply as an illustration, as a counterexample, really, to a rather crass, in my view, reductionist thinking of materialism. That there is at least this dimension of reality, which has these surprising properties, and which does seem to be a dimension of reality rather than, as I say, a sort of human confection, something made up to, like a Sudoku puzzle. That just enlarges it. Now, of course, I mean, God is much more complicated than mathematics, that's for sure, but it carries this in that sort of way. Yeah, your last point I've forgotten.
The quest for certainty, but first, abstract mathematical objects being co-eternal with God, because you say reality beyond the material.
Yeah, but I mean, it isn't that here's the material and here's God. I mean, there are lots of. I mean, you and I are beyond the merely material, but we're certainly not divine. So I mean, reality is multi-layered, and there are lots of puzzles about how the different layers relate to each other. But I mean, I think to me, it's important to try and recognise that there are these layers. As for certainty, I mean, I think certainty is a will-o'-the-wisp. I don't think we can have it in some absolute sense. I say we can have beliefs that are very well motivated and we can commit ourselves to, but they can't. I mean, it all connected, of course, in some ways with the problem of induction. I mean, will the sun rise tomorrow? Well, probably, but can't be absolute. Yeah.
I think we'll take one last question, I'm afraid. Which of you wants to?
The video's choice. You make it quick. Are we up to?
Yeah, make it quick. Excellent.
Are you, in principle, against the theory of everything?
Yes. Yeah, yeah, the answer to that is yes, I am against it. Yes.
Short question, short answer. Brilliant.
I certainly don't think it's string theory. That's
comparing the progress in science and religion knowledge, but on a personal level. Okay, so if you found something utterly new, it pushes you to somehow reorganize or rearrange your attitudes or knowledge which you had before, which seems to me quite similar to the progress in faith. But also, you go on another level, and the previous levels should be reorganized. So it's just a comment, if you can.
Yeah, well, I think it's a helpful comment. Yes, I mean, I suppose that the great paradigm example that I've written is Paul's conversion on the road to Damascus. And it's very important. I mean, particularly in chapters 9, 10, and 11 of the Epistle of the Romans, and he's very much saying, I don't reject in any way my Jewish heritage, but there's more to be said.
Well, thank you very much. We've worked John really hard this morning, and he's game enough to come back for more this evening. So do please put questions in the box to kick off the discussion this evening. And lunch will be at 1 o'clock, so it's just half an hour to recover your breath. And it remains to thank John very much once again.